Today we're going to solve radical equations. So remember, radical just means some kind of root, so it could be a square root, a cube root, a fourth root. A radical equation, remember, equations just are two expressions separated by an equal sign. So a radical equation is an equation in which the variable appears in a radicand. So here's a couple examples. So notice the x is under the fourth root in this one, and in the second example the m is under square roots. And these are equations because they have that equal sign. So let's try an example, and what we're going to use to solve any radical equation is the principle of powers. So what that says is if two sides of an equation are equal, then we can raise both sides to any power or any exponent. It's a little different when n is negative maybe, but otherwise we're not going to deal with negative exponents on this. So that's how we're going to undo roots. So for example, if an equation has a square root, we undo that by squaring, because the opposite of a square root is being squared. So if the equation has a cube root, we're going to undo that cube root by cubing. But anytime we do something to one side of an equation, we have to do it to both sides. And that's what the principle of power says, is that I can raise both sides of any equation to any power. So hopefully we get the idea. If it's a fourth root, fifth root, we would just use that index in the radicand to decide what exponent to raise both sides to. The only other thing we got to remember on this is that we always have to get the radicand alone on one side of the equation. So in this first example, notice that the plus 3 is not under the line, right? It's not part of the radical. So therefore we have to get that plus 3 and move it to the other side. The opposite of plus 3 is minus 3. So I just subtract 3 from both sides. That gives me the square root of m equals 6. And now I have the radical alone, and I'm used that a little improperly. It's just the radical. The radicand is what's under the radical, which I guess now we want to get that alone too. So to undo the square root, I'm going to square both sides. And what I get, the square and the square root undo each other, so we just get m, and 6 squared is 36. So great, we solve for m, because solve always means get the variable alone on one side of the equals. But with the principle of powers, we have to check our answer. We could get what's called an extraneous solution, meaning even though we did all our steps right, this answer at the end might not make the equation true. So we do need to check always on these. Checking's not hard. You just plug it into the original equation. So square root of 36 plus 3 equals 9. That's what I'm checking. 6 plus 3 equals 9 definitely checks out. So we do have the correct solution, and we could even put it in curly brackets as a solution set. All right, let's look at this as more of a process. The caution just is a reminder that we have to check the answer. Raising both sides of an equation to especially even exponents may not produce equivalent equations. And what that means is that we have to check our answers to these. So if you like more of a step-by-step process, first step is always isolate the radical on one side of the equation. We have to get the equation to look like a square root equals something, or a cube root equals something. We can't have anything else with the square root or cube root on one side of the equation. Then we use the principle of powers, meaning raise both sides of the equation to some exponent, and always check. So let's try one with a fourth root. So first step, get the radical alone on one side. So first step is to subtract 4. So it's really important to notice when is a number under the line part of the radical, or when is it separate. So we need to move the 4 over. So that would give me the fourth root of 5x minus 1 equals negative 3. The way to undo this fourth root is to raise it to the fourth power. Fourth power and fourth root undo each other. So all we get left with over here is 5x minus 1. Negative 3 to the fourth power. Notice I use parentheses here. It's the entire side of the equation that's being raised to the fourth power, not just the 3. So the negative is part of this. And in that case, this is the same as negative 3 times negative 3 times negative 3 times negative 3. And 4 negatives make a positive 81 over here. All right, almost done. Now it's just a solve for x problem, right? I don't have any square roots or fourth roots in there. I add 1 to both sides. I get 5x equals 82. Divide both sides by 5. 82 divided by 5. Well, we could leave that as a fraction. We could write it as a decimal. I'm going to do a long division because I don't have a calculator handy. 5 goes into 8 once with 3 left over. 6. So you could probably use a calculator. I got 16.4. So the 6 is because 5 goes into 32 6 times. And then the 0.4 is 2/5. So the remainder of 2 over 5. But yeah, that's definitely a calculator. I just didn't have one handy. 16.4. Are we done? No, we have to check that answer. So I'm going to check by putting it into the original equation. So 5 times 16.4 minus 1 under a fourth root, then plus 4, and we want to know, does that equal 1? All right, well, we can stick this in a calculator. If you stick just the part that's under the fourth root under a calculator, you get fourth root of 81 plus 4, does that equal 1? And no, 3 plus 4 does not equal 1. So this is not a solution. Sorry, I'm a little off the screen there. So now we have to wonder, well, what is the solution? Is there any? And we did all of our steps right. Like, that's always one thing to check when you get something that doesn't work out. So here the answer is just that we have no solution. So this is the symbol that means no solution, or you could write it out in words, no solution. There is no x value that would make this equation true. So that's why it's so important to check. Let's try another one, and hopefully the solution checks out, but we never know. So in this next one, first thing to recognize is that the 1/3 power is the same as a cube root. So if it helps you, you can write that as cube root of 3x plus 4. Right? That way maybe it helps you remember, oh, I need to cube to undo it. But you could cube both sides and undo the 1/3 power. It works the exact same as a cube root. But I definitely want to add 2 to both sides. So I'm getting that the cube root equals 2. To undo a cube root, we need to cube. So that gets rid of the radical. So now I just have 3x plus 4 because cubing undoes the cube root. And 2 cubed is 8. And now it's just a simple solve for x. We got rid of all the radicals. So I just need to subtract 4 from both sides. So 3x equals 4. Divide both sides by 3. So x is 4/3. Don't let fractions and decimals freak us out, right? They happen all the time. We can still check it. Oops, sorry. So let's check this one. So I go to the original problem, and if you want to write that 1/3 power as a cube root, that's fine for checking. Cube root of 3 times 4/3 plus 4 minus 2, does that equal 0? So we can either put this in our calculator, or these 3's actually just cancel. So this becomes the cube root of 8 minus 2. Cube root of 8 is 2, and 2 minus 2 does equal 0. So it does check out, and therefore our solution is 4/3. All right, let's do one more, and then we'll take a break. In the next video, we'll do some more complicated ones. Not that these aren't complicated enough, but they get a little bit harder. But this one, what's different is that it takes us a couple steps to get the square root alone. So remember, the goal is we have to get that radical by itself. So we have to decide, which do I undo first, the 20 or the 7? Order of operations says that this multiplication is really tied here, and the plus 20 is what we can undo first. So I'm going to subtract 20 from both sides. That gives me negative 14 equals 7 times the square root of x plus 4. Now, before squaring to undo the square root, I still need to get it alone. So I'm going to divide both sides by 7. And that gives me negative 2 equals the square root of x plus 4. To undo a square root, we need to square. Again, using parentheses, so it's the entire left side of the equation I'm squaring. Just like it's the entire right side. It's not just 4, just x that I'm squaring, it's the whole thing. Negative 2 squared, since the negative 2 is part of the squaring, that's just a 4. And on this side, it's x plus 4, because the square root is undone by the squaring. Then I just subtract 4 from both sides. And we get x equals 0. Now this is another one, just like ugly numbers, sometimes people freak out when they get the answer 0, but it's no big deal. We just check our answer, and then we'll know whether it's right or not. So let's check. 6 equals 20 plus 7 times the square root of 0 plus 4. The square root of 4 is 2. And sometimes that question mark makes it clear. I'm checking. I don't know whether this equals 6 or not. 20 plus 7 times 2. Yeah, that's not going to equal 6. 6 does not equal 20 plus 14. So this is, again, no solution. Or you can use that special symbol. Before we end this video, let's take a moment and see what the two that had no solution had in common, because there's actually a trick here. In this first example, we had an even root, like a 4th root, just like square root, and it equaled a negative number after we solved for it. That is actually the key to having no solution, because square roots and 4th roots have to be positive numbers. So here, same thing, I got that the square root was equal to a negative number. That's never going to check out. So that's one thing that if you notice as you're solving this, that you get an even root equaling a negative, you can just jump to no solution at that point.